Hey everyone, it's Marques here and welcome back. Today we're tackling overlapping interference. We've all been there, right? Streaming your favorite show, downloading a huge file, or on an important video call and suddenly lag, buffering, that dreaded spinning wheel of doom. Let's break it down and find out how to keep those signals clean and your connections strong. First up, frequency overlap. Imagine a bunch of people talking at the same time on the same frequency. Chaos, right? That's what happens when signals from different transmitters use the same frequency band. Think about your Wi-Fi at home. If your neighbor's routers are on the same channel, it's like a digital traffic jam. Now, let's look at co-channel interference. It's like two radio stations broadcasting on the same frequency in the same city. Pure static. At a crowded event, everyone's phone fights for a connection on the same network, leading to dropped calls and slow data speeds. Next up is adjacent channel interference. Think of two neighbors mowing their lawns with loud lawnmowers. Even though they're on different parts of their property, the noise still bleeds over. In telecommunications, this happens when signals from one frequency band spill over into neighboring bands. Now, let's get into intermodulation interference. It's like mixing different colors of paint together, creating a new, unwanted color. In signals, this happens when two or more frequencies mix non-linearly, creating new, unwanted frequencies that interfere with legitimate signals. Ever been on the phone and heard someone else's conversation? That's crosstalk. It occurs when signals from one communication channel bleed into another. This can happen in telephone lines, network cables, and audio systems. Now let's talk about the consequences of interference. One of the most noticeable effects is reduced signal quality. Imagine trying to stream a 4K video, but the signal is weak and constantly interrupted. Another major consequence is decreased throughput, meaning slower data speeds. Interference creates congestion in the network, slowing down data transmission. Think of it like a highway. When there's no traffic, cars zoom along, but when it's jammed, everything slows to a crawl. The same principle applies to data transmission. Ever been in the middle of an intense online gaming session and suddenly disconnected? That's the worst. Often, overlapping interference is to blame. Severe interference can cause your connection to drop completely. And then there's latency, the silent killer of real-time applications. Latency is the delay in data travel from source to destination. Interference can make latency much worse. Imagine a video call with noticeable lag. That's latency in action. Now, let's get to the good news, the solutions. Strategies include smart channel planning, using modulation techniques like OFDM, and employing filters to block unwanted frequencies. We can also control signal power and spread the signal over a wider frequency range to make it more resilient. That's it for today's video. We've covered the types of interference, the problems they cause, and the ways to combat them. Understanding these concepts can help you troubleshoot your tech issues more effectively. If you found this video helpful, give a thumbs up, subscribe, and hit the notification bell. Thanks for watching.